So we continue with Polynomials unit, lesson number 4. Last day we looked at how to do long division and synthetic division, and it kind of ties in on this lesson here. So it says review here, but it actually ties into a very important concept. So we're going to work through that. Use synthetic division to divide x cubed minus 2x squared minus 4 by x plus 1. So if you recall, we go like this. Okay, x plus 1 you're going to set equal to 0 so that you know, solve that for x equals -1, the -1 gets set up there. The coefficients of all the terms go across here. If we're missing a term, as in a certain degree, so we have x cubed, x squared, we do not have an x term, so we need a 0x, okay, for a coefficient. So 0 and then finally -4. Okay, so carry the 1 down, multiply, -1 times times 1 is going to be -1. We add -3, multiply again, we get 3, we add, multiply -1 times 3, we get -3, and finally we add to get -7. Exactly what we did in the last lesson. Okay, this is our remainder. Okay, now in addition to that, actually, before we move on to the next one, I'd like you to try B as well. So pause your video and you guys do B, and then unpause. We'll see if we get the same answer. Okay, so we should have gotten a remainder of -5 on that second one. Okay, now what we're going to do here on the right-hand side of the page is you're asked to calculate P at -1. So we are replacing x with -1 everywhere you see x. So run through, scoop x out, and put in a -1. It's important that you use brackets here to scoop this out so that on situations like this part here, we're going -1 squared, and we actually are squaring the negative as well as the 1. Okay, so work out what that would be. -1 cubed is -1. Minus 2 times, that would be 1, because you square -1, it would just be 1. And then when we add all these together, they're all negative, so they add together to get -7. Notice something? Okay, let's see if this other one works that way as well. It appears that our answer when we went P at -1, we got the same as our remainder. So if that's the case, that would mean on this one, we should also get -5 when we sub in 2. So let's do that. Okay, simplify that. So P at -2, 2 squared 4, -2 times 2 is going to be -4 minus 5, and look at that, we get -5. So P at 2, and that 2 is coming from here, is equal to our remainder. So to summarize, when P of x is equal to x cubed minus 2x squared minus 4 is divided by x plus 1, that's our first question on the review there, the remainder is equal to P at -1. And when it was divided by x minus 2, our remainder was the same as P at 2. Okay, well guess what? That is our remainder theorem. That's part of what we're looking at today. For some reason the bottom half of my page got cut off, so I will fill this in. So the remainder theorem states when a polynomial function p of x is divided by a binomial x minus a, the remainder obtained is equal to the value of the polynomial when x equals a. Okay, and you do that by just going x minus a equals 0, add a to the other side. There we go. Okay, so the remainder is equal to p of a. In other words, r, the remainder, is p at a. So we have a little proof for that below. The division algorithm states p of x equals d of x times q of x plus r of x. That was from the last lesson. Actually, we first looked at that in lesson 2. Using x minus a, so we're dividing by x minus a as the divisor, we get p of x equals, and so they subbed in for the divisor x minus a. Okay, and then if we actually want to figure out p at a, we substitute a in for x. So we have p at a equals, and then a in for x, so that would become a minus a, and we'd have q at a plus our remainder. Okay, and then if we simplify that a little bit, a minus a is 0, and we're multiplying that by q at a, and then we have plus the remainder. Now 0 times anything is going to be 0, so what happens is p at a therefore would equal 0 plus r, or just r, our remainder. Okay, little proof on why the remainder theorem works there. Okay, good. Let's take a look at the next page. Okay, so we're going to use remainder theorem to find the remainder when p of x equals yada yada is divided by x plus 1. Okay, so make our divisor equal to 0. Okay, it doesn't want to stay. Hang on. Okay, so it's equal to 0. Solve that for x. So to solve that, subtract 1 to the other side. And then what we're going to be doing is we have our polynomial function. Always write this down first, okay, so that you can see what you need to sub in for. There we go. And now we want to figure out what p at whatever our x value is, so -1, equals. And that should be our remainder, which is basically using remainder theorem. So scoop x out everywhere you see it. Run through, put brackets, then put in your value for x, -1, okay, and then simplify this. Okay, and when you do that, you should end up with -4. So that means our remainder is equal to -4 when we're dividing by x plus 1 for that polynomial. Okay, let's try it with this one. So we're dividing by 2x minus 1. That's our divisor. So once again, you want to set it equal to 0. And we solve for x. So add 1 to the other side, then divide by 2, and we would have x equals 1/2. Okay, so once again, we're writing down our polynomial. Oops, sorry, not quite there yet. And now we're replacing x with 1/2. So you run through, put brackets where x was, and then insert the 1/2 for x. Okay, so then it's a matter of number crunching here. Now, if you're a student headed for calculus, Math 31, you probably want to do this by hand, okay? If not, then feel free to pull out your calculator, okay? So I'm going to walk through it for those of you taking calculus next. So, no calculators in calculus for some professors in university. Okay, so we have 6. We first do exponents, cube the 1. So 1 cubed is 1. 2 cubed is 8. 2 times 2 times 2. Okay, over here, change, actually we'll do that on the next step. Just write this down again. All right, so now we're going to multiply 6 times 1/8. If you make 6 a fraction as well, then we multiply the numerators, multiply the denominators. But we could reduce first. So 6 and 8 have a common factor of 2. So divide by 2, we get 3. Divide by 2, we get 4. And you can do that as long as the one thing is in the numerator, the other one in the denominator. Okay, so then we have 3 over 4 minus, do the same thing here. If you can't tell that half of 4 is going to be 2. Okay, but divide by 2, and you get 2 times 1 over 1 times 1. So just 2. Same thing with the 8. Okay, and then we simplify this a little bit. Group these ones. That's going to be 10 minus 2 is 8. So now we're down to 3/4 plus 8. So we need a common denominator. So we want to make 8 over 1 and then get a common denominator. So it'd be 3 over 4 plus and 8 over 1. So we need a common denominator of 4, which means we multiply this top and bottom by 4. 8 times 4, 32. Okay, add the numerators now that our denominators are the same. 3 plus 32 is going to be 35 over 4. Okay, if you are not headed towards Math 31 and you did that on the calculator, just remember to go Math fraction at the end so you can get a nice fraction. All right, let's look at the next example. Find A if the remainder is 131 when P of X equals yada yada yada. You'll notice we're missing A, or we're missing a coefficient in that polynomial. Okay, we're dividing by x minus 3. So x minus 3 equals 0, x would equal 3. We need that not only for a synthetic, but also remainder theorem as well. Okay, so using synthetic division, okay, we would put 3 there because we're dividing by x minus 3. Our coefficients go across the top to -1, -a, and +8. Okay, so why don't you guys, well, actually you're going to have trouble because of the a, so carry the 2 down, multiply. I think maybe you had some like this on your last lesson though. Okay, and then we end up here. So we have to go -a plus 15. That's what would go in that spot if we knew what a was. And then we multiply by 3, and we would have -3a plus 45, right? 3 times -a plus 15. And then we would go 8 plus -3a plus 45. And we get, add those a little bit, we would get, oops, sorry about that. Okay, we would get -3a plus 8 plus 45 is going to be 53. Now, we know that we were supposed to get a remainder of 131. So this here needs to equal 131. So we take that off to the side. Okay, and then we solve for a. Hang on, I'll do that. You do it as well, and then we'll check. Pause the video. Okay, so solving that equation for a, we should have ended up with -26 for our a value. Now, let me show you a much easier way. Okay, using remainder theorem, if we take our polynomial, p of x equals 2x to the 4 minus x cubed minus ax plus 8, and we simply sub 3 in for x, just like before. Everywhere you see x, you're replacing it with 3. Okay, let's simplify that as much as we can. So we'd have 81 times 2, 162, minus 27, minus 3a plus 8. We have some constant terms we can put together. So that would be, I would add the 8 to the 162 if you're doing this in your head. That gives you 170, which is easier to take away 27. So that would be 143 minus 3a. Okay, but what's on the left-hand side? Well, we know using remainder theorem that p at 3 equals our remainder, right? P at 3 should equal, what's our remainder? 131. So we put 131 in here, subtract 143 to the other side, and it doesn't look like we're going to get the right answer. Hang on. Okay, so even teachers make mistakes, you guys. Did anybody notice on my synthetic division that I was missing x squared term? That's what I did wrong. Okay, and this is another reason why remainder theorem is the more efficient way to do this, because if I would have continued along with this 170, I would have had 143. Then I subtract 143 over, I'd get -12 equals -3a. Divide by -3, I get 4. That's a much easier way to do it than this big mess I did over here, because here's what I forgot. I forgot to put a 0 there. So I would have had a 15, and then 15, and then I multiplied by 3 to get 45, and that would have been a 45. And then this would have been 3 times 45, 135. And then this, 135. And this would have been, add 8 to that, 143. Okay, so this here, 143. And then when we subtract that over, we would get negative 12, and then we're down to what we have. So it's a good check. So if you had that on a test, good thing to do to check that. So we should have a equals 4. What's the better way to do it? That way. Okay,